screen here. Let's make sure it's coming through here. Just want to finish the problem I said I'd finish before, the insurance problem, the latter part where we discuss some other things and do some more computations. Just checking to see that my video's coming up okay. It's being heard and everything. Putting it up so that I can see any comments if anyone happens to be watching. Okay. Think about it all. Get through that, get this out. Set this up in advance. Apologies. Off kilter, but I think we'll survive. Okay, so continuing the problem as I promised. So this, just to remember, this is from the 6th problem set, uncertainty, the insurance problem. We did 1A yesterday, and now we'll do 1B. Okay. So to remind the setup, there's a 50-50, the individual starts with 20,000, 50-50, let's say 1/2 chance loses 10,000. Okay, so we calculated the cost of fair insurance would be 5,000, and we showed that the person would indeed purchase fair insurance rather than remain vulnerable to this risk, using the old utility of income diagram. So this is income in thousands of pounds, this is utility, this is the utility of incomes for certain, it's increasing at a decreasing rate. We had utility of 10,000, utility of 20, we had 20,000, we had the utility of 10,000, we had the utility of 20,000 up here, and then we noted that if they're uninsured, their utility of having this uncertain income, which I'll call Y tilde, is equal to half their utility from 20,000 and half their utility from 10,000. So it's halfway between here and here, which we can show geometrically is also the point on the line connecting this point and this point. If we project up from halfway between here and here, namely 15,000, so this is their utility of being uninsured, when they're facing this risk, half the time here, half the time here. Here's the utility of being uninsured, but if they were given actuarially fair insurance, they would have to pay 5,000. But then, if they suffered a loss bringing them to 0, they would be fully compensated, bringing them back to 15. So, and if they don't suffer a loss, they just end up with 15. So that would be getting 15,000 for certain, which would yield this level of utility up here, which is greater. Okay, so they would choose to buy insurance if it's actuarially fair. And we also could consider what is the most they would be willing to pay for insurance. Well, it would be the insurance cost that would take them to this point. In other words, it would be however much it is that takes you from 20 to this point. Because if I have this income for sure, I get the same utility as if I have a 50% chance of 10 or 20. These are on the same vertical line. Okay, so the most they would be willing to pay would be whatever it is, the distance is between 20 and this point. Okay, now we get to problem B. Part B, I mean. Okay, suppose that two types of insurance were possible: a fair policy covering the complete loss and a fair policy covering half of the loss incurred. Calculate the cost of the second type of policy and show the individual will regard it as inferior to the first type of policy. Okay, so the damage is, the cost of the loss is 10,000. I could buy insurance that if I lose the 10,000, if I do fall ill and I lose the 10,000, will pay me back only half of that. Okay, so what would be the cost of such insurance if we're actuarially fair? That is, what is the expected monetary value of the amount the insurance pays? So if we have a risk-averse insurer, that's the cost to said insurer. So we said partial insurance would pay half the time, so it would pay half the loss, so not 10,000 to 5,000, and then the remaining half the time it would pay 0. So the expected payout would be equal to 2,500. Okay, so now suppose the person bought such insurance, this actuarially fair insurance. By the way, this is always increasing, never decreasing, but it's very shallow. Well, the person buys such insurance, and then there's two possibilities, okay? It's not full insurance, it's partial insurance. So they buy such insurance, it costs them $2,500, and then if they don't suffer a loss, they end up at this point, 17.5, which yields them a utility up here, the utility of 17.5, whatever that is. Okay, U of 17.5, because you paid $2,500 for the insurance, and that's it. Okay, or after having bought the partial insurance, they do suffer a loss. Okay, remember the loss is 10,000, so the loss takes them down to 7,500, way down here, but then they're compensated for half of that loss. So what do they end up with? Well, they started with 20,000. They paid 2,500 for the insurance. If they suffered the loss, they lost an additional 10,000, but then they were paid back half of that loss, so they gained back 5,000 of the 10,000. So we have 20,000, 17,500, 7,500, 12,500. Okay, so if they have the partial insurance, they purchase the partial insurance, then half the time their utility is the utility of 17.5. That is, if there's no loss suffered. And half the time their utility is the utility of 12.5, which happened to seem to, well, the way I drew it, intersect with that point, so I don't want to do that because that's confusing. So that was just a coincidence. So the utility, half of the point halfway between here and here, project up to some point. So we have the utility of 12,500. So it should be the point If they buy the partial insurance, their expected utility is half of this, with 1/2 probability they get this utility, and half of this, with 1/2 probability they get this utility. It should be the point halfway between here and here, which we can use the same geometric argument to show that it's the point halfway between here and here, projected up onto this arc, and then projected over to here. Okay, and we can see that this point is still obviously below this point. The utility of having 12.5 half the time, the expected utility of having 12.5 half the time and 17.5 the remaining half of the time, or half the utility of 12.5 plus half the utility of 17.5, this point here. All right, so this is 1/2, still on the board yet, 1/2 utility of 12.5 plus 1/2 utility of 17.5. This point here is still below this point here. It's still below the utility of having 15 for certain. So fair partial insurance is less desirable than fair full insurance when someone's risk averse. Well, that's not surprising, because having this half the time and this half the time is an expected monetary value of 15, but we know that a risk averse person always prefers the expected monetary value over, for certain, over a gamble. They always prefer to have 15 for certain than any gamble that involves some risk with the same expected value. They would be unwilling to take a fair gamble, right? Moving from this for certain to having this half the time and this half the time is like saying you have 15,000, would you like to take a 50-50 coin flip bet over gaining or losing 2,500? They're risk averse, they would say no. All right, so I think I beat that question to death. So they will regard this as inferior to full insurance. And now I added a computational question, making this computational, which I really think it's important to cover. All right, so extension to the second question. Suppose this person's utility function, the thing that describes this curvature, suppose it has the following functional form. Okay? Suppose we have the utility of a particular level of income, let's call it V, I don't know why I called it V, is equal to that level of income to the power 1/3. That's the cube root, I believe, the square root of this, the cube root, whatever. Yeah. Square root, is that the square root of the square root? I think so. Okay, what is the maximum amount that they would be willing to pay for full insurance? So what I'm asking you, all right, let's forget about the partial insurance now. Let's clean this up a bit. Yeah, I'll just redraw the thing. It's not too hard to do. Okay, so without insurance, half the time they're at 20, half the time they're at 10. They have some utility function which is described by as income increases, so I call this V for some reason, I can't remember why. So as their income increases, their utility increases, yes, but at a decreasing rate. All right, the derivative of this is 1/3 to the negative 2/3, and you can see that that has a gradually, if you want to use the calculus, that slope gets more and more shallow. Okay, the second derivative is negative if you want to get fancy, but that's okay, you don't have to get fancy. Okay, it's increasing at a decreasing rate as before. So this is the utility of income. Utility, you call income V for some reason, I can't remember why. And let's say it's V to the 1/3. So we know that if they're uninsured, half the time they get the utility of 10, half the time they get the utility of 20. And their expected utility, we can see this by, is halfway between the utility of 10 and the utility of 20, the little utility. Their expected utility is half of this plus half of that. We see it geometrically by going halfway between here and here, projecting up to here and projecting over to here. So this is 1/2 utility of 10 plus 1/2 utility of 20. Okay, but I can say more than that now. I actually know what this is because I have this little utility function. Okay, so in fact, the utility they will get from half chance of this, half chance of that, is 1/2 10 to the power 1/3 plus 1/2 20 to the power 1/3. Okay. Okay. So now, what am I looking for? I'm looking for the maximum they would be willing to pay in order. The maximum they'd be willing to pay for this insurance. In other words, what is the certain income that they could be left with that would leave them as well off, that would lead them to the same utility as they were without insurance? And then whatever that point is, the difference between that point and 20 is the most they'd be willing to pay for the insurance. So I'm trying to find what this point is. Okay, so we can solve for her utility under no insurance. We did so here. Okay, we could compute that. And then we need to say what is, so we compute what this level is, then we have to say, okay, what is the certain income that gets me to this point? How far along this do I need to be in order to get me to whatever this point is? Let's do this computationally. Okay, the diagrams in the handout are in the suggested answers to this are obviously better. Okay. Trying to figure out what is this big blue dot. It's black now. It got corrupted. Okay. All right. So without insurance, we'll call this. I don't know how to use this notation, but that's okay. This utility we'll call UA. So UA is equal to 1/2 the utility of 10,000, V of 10,000, plus 1/2 the utility of 20,000, V of 20,000, or 1/2, as we just said here, I'll just take the 1/2 outside, 1/2 10,000 to the power 1/3 plus 20,000 to the power 1/3. And I can compute this approximately, let's say using a calculator. It's going to be approximately equal to 24.35. Okay, so now I need to say, okay, what level of income do I need to get a utility? What level of certain income do I need to get a utility of whatever this is, which is about 24.35? In other words, I need to answer the question, what value of V makes this equal to about 24.35? So I can ask a question with an equality, in a sense. So I can say, I need to know, solve for V to the 1/3 is equal to 24.35. Let's see how I did the calculation before. Yeah, or in other words, let me call it Y, okay? Level of income Y. So YA to the 1/3, the utility of YA to the 1/3, utility of certain income, YA, whatever this point is we're looking for, utility of this must equal 24.35. Okay, this point here. So I can do it without, there's obviously a few ways I could do this. So in other words, what I need to do is, if I cube both, so I know YA to the 1/3 is equal to this. If I cube both sides, that will get rid of this exponent. Okay, so let's do that. So say that YA to the 1/3 cubed is just YA. So that's equal to basically 24.35 cubed, or let's use the full thing here to be precise, 1/2 10,000 to the 1/3 plus 20,000 to the 1/3, all taken to the power of 3. And if we compute this, we get a number approximately equal to 14,437.6. Okay, so this is approximately the amount of income she needs to be left with after purchasing full insurance to make it worth doing. But we haven't finished answering the question, because the question doesn't ask you how much does she need to be left with. The question says, what's the most she's willing to pay? Am I still recording? I hope so. Hello. Is it still recording? Seems to be. Okay, just wasn't broadcasting. Okay, we're back. Okay, so how much does she, so I said this is how much she needs to be left with. So this point is approximately equal to 14.4K. But the question wasn't asking how much does she need to be left with. The question was said, how much is she willing to pay? So actually we need to just look, what is the difference between this point and this point? So it's just simple subtraction. Okay, so so she's willing to pay approximately, so if she's, in other words, the point is, she ends up with the amount of, if she buys full insurance, she ends up with 20,000 minus the cost of full insurance. So 20,000 minus the cost of full insurance, which is here is about 14.4, sorry, 20,000 minus, sorry, minus I'm being dumb here, 20,000 minus whatever, sorry, my brain's a bit dead here, 20,000 minus the price of the insurance, I'll call it P full insurance max, must equal approximately 14.4 thousand. So in other words, we can just subtract 14, remove this around, so we have 20,000 minus 14.4 thousand is approximately the maximum she'd be willing to pay for this insurance. So this is approximately equal to 5.56, whatever, thousand pounds is the most she'd be willing to pay for the full insurance. She'd be happy to pay less, but she'd be willing to pay up to that amount. Okay, I think this fully answers that question. There's a similar question. The holiday insurance problem is similar. Now that you know how to do this one, I think you should be able to also do the following holiday insurance question with a slightly less standard setup. All right, have a great weekend.